This is Mr. Beck Does Your Homework, AP Physics, Homework 8.2, question number 4. Pure helium gas is admitted into a tank containing a movable piston. That should be familiar. The initial volume, pressure, and temperature of the gas are 0.057 meters cubed, 200 kPa, and 447 Kelvin. If the volume is decreased to 0.01 meters cubed and the pressure is increased to 469 kPa, find the final temperature of the gas. Answer in units of Kelvin. Well, I could go at this with PV equals nRT and solve for my initial, let's see, my initial n. So you could solve for n using these three and r, and then use that same n and plug in PV and get to temperature again. But that's the tough way of doing it, because I know that if n is the same and r is the same, then PV over T is going to be a constant. So P1 V1 over T1 is going to equal P2 V2 over T2. What this does for you is it makes it so that you don't even have to convert kilopascals into pascals, because this one will push out units for pressure and volume that are whatever pressure and volume units you put in, that'll be the pressure and volume units you get out. Whatever temperature units you get in, as long as it were an absolute scale, would be the temperature units you get out. But the thing is, the only absolute scale we use is Kelvin. So yes, you do need your temperature in Kelvin, or Tink as I like to say. So I've got initial pressure, initial volume, and initial temperature. My initial pressure is 200 kPa. My initial volume is 0.057 meters cubed, and my initial temperature is 447 K. That's going to equal my new my new pressure, 469 kPa, my new volume, 0.01 meters cubed, and my new temperature. So just make sure you don't leave this in the denominator. So cross multiply, solve, and you can get your new temperature in Kelvin equals such and such. Okay. So if you were given liters, that would be fine here. If you were given pressure in atmospheres, that would be fine here. So if they're on both sides, you don't have to do the conversion. If you're doing Pivnert, then you do have to do the conversions. But absolutely temperature in Kelvin.